So 1 and 2 on the 9-3 warm-up are covering what we covered last time about hyperbolas. So we talked about hyperbolas being the last conic that we're going to cover. And they look like two parabolas pointing outward, or two, and those things are called branches, okay? So a quick refresher that there's two different kinds of hyperbolas. There is a horizontal hyperbola, and there's a vertical hyperbola. And how you know the difference is what comes first, because there's a minus this time. So the horizontal is x minus h squared over a squared minus y minus k squared over b squared equals 1. And the vertical is y minus k squared over a squared minus x minus h squared over b squared equals 1. So the difference between ellipses and hyperbolas is that the ellipse, the a squared, is always the larger. With the hyperbola, the a squared is first. And that's how I know if it's horizontal or if it's vertical. Both of them still have a center at HK. You just have to be careful and not assume that this is always going to be the h, right? The h is with the x, so don't make that mistake. The distance from the center to the vertex is still a. So that's the same as the ellipse. The b is still centered to co-vertices, which is the same as an ellipse. The c is still the distance from center to the focus, which again, still same as the ellipse. Another major difference is that c squared equals a squared plus b squared this time, whereas with an ellipse it's a minus. And then these have asymptotes. So for a horizontal asymptote, the equation is y equals k plus and minus b over a times x minus h. And for a vertical, it's y equals k plus and minus a over b times x minus h. So the change there comes in the a over b or b over a. If it's horizontal, it's b over a. If it's vertical, it's a over b. So that is kind of what we talked about in the first part of 9.3, the introduction into hyperbolas, how to graph them, how to find all those pieces of information. So that leads us into this. So number 1 says find the standard form of the equation of a hyperbola with foci negative 1, 5 and negative 1, 1 and vertices negative 1, 2 and negative 1, 4. So if this were to happen on your test and you don't have your graph, you want to make sure you can kind of graph it as accurately as possible. So foci negative 1, 5 is here and negative 1, 1 is here. And then vertices negative 1, 2, and negative 1, 4. So just from that little bit of information, you should already be able to tell me what about this hyperbola. It's vertical, which means what's coming first? X. What else can you tell me about? Just kidding. Making sure you're paying attention. Y squared minus x squared. What else can you tell me? Center would be halfway between the vertices or halfway between the foci. It doesn't matter which one you use. Okay, either way, that's negative 1, 3. So already I've got y minus 3 squared minus x plus 1 squared equals 1. I already have half my equation. All I'm missing is the a squared and the b squared, right? So we said the a squared comes from the distance from the center to the vertex. That's 1. B, I need co-vertices for. I don't have that, but what I do have is center to focus, which is C, is 2. And I know c squared equals a squared plus b squared. So 2 squared equals 1 squared plus b squared. And b squared is 3. So the y goes over the a squared. A is 1. That would be 1. The x goes over the b squared. B squared is 3. You don't need the 1, but it's certainly not wrong to include it. All right, 2, put the equation in standard form. Identify the center of the vertices, the foci, and the asymptote. So this is not in standard form. What do I have to do to get it into standard form? Complete the square. Again, good review, because you can complete the square in your test with a parabola, with a circle, with a ellipse, or with a hyperbola. So I'm going to group the x's and the y's. This would be a -4, so that negative stays on the y. And then I'm going to bump that 43 to the other side. Take out the term on the front of the squared. So 9 times x squared minus 2x plus, I'm actually going to take out a -4 because that has to be a positive. Then I take my second term, divide it by 2, and square it. So 2 divided by 2 is 1. 1 squared is 1. I add that here. Before I add it to the other side, I have to multiply it times that 9. So I'm going to add 9. Repeat the process for the second set of parentheses. 4 divided by 2 is 2. 2 squared is 4. Add it here. And again, multiply it. This time I'm multiplying by a -4, which means I'm actually going to subtract 16. Everybody with me so far? Questions? All right, so now I'm going to factor my trinomials. 9, square root first, square root last, sign from middle. 4, square root first, square root last, oops, sign from middle. And then this is 52 minus 16, this is 36. Is that in standard form yet? Nope. What do I have to do? Good. Divide everything by 36. So I get x minus 1 squared over 4 minus y minus 2 squared over 9 equals 1. So that's step 1. Put it in standard form. Obviously, it's super important to do that carefully, because if that's wrong, everything after this is also wrong, right? Make sure you're really careful. So from here, my center is the next thing it tells me to identify. Is 1, 2, opposite of what follows x, opposite of what follows y. My a squared is 4, which makes a 2. My b squared is 9, which makes b 3. It's going to ask me to identify the foci, so I can say c squared equals a squared plus b squared. C squared is 13, so c is the square root of 13. Which I'm going to use that to get the foci. And then it also asked me to get the asymptotes. I can get those already. Y equals, is this a vertical or a horizontal hyperbola? Horizontal, because the x comes first, right? So this is k, which is 2, plus and minus b, which is 3, over a, which is 2, x minus 1. There's my asymptotes. Now, it didn't say to graph it. Obviously, you're going to get asked to graph at some point, so it's good practice. But it's also, for me, easier to identify my vertices and all that stuff if I graph it, because I get the visual on it. It doesn't mean you have to, okay? But if that's the case, I will give you a graph so that obviously it's accurate. So I'm going to find my center, 1, 2. And we said it's horizontal, so I'm going right and left my A. To the right 2, to the left 2. Those are going to be my vertices. I'm going to go up and down B, up 3, down 3. Those are my co-vertices. And then for a hyperbola, we make a little box going through the B's and the A's. And we cross the asymptotes through the corners of that rectangle. And then we said this is horizontal, so I know it's coming off those vertices. And it's going to be as wide, making my branches as wide as I can without intersecting the asymptotes. So from my graph, I can identify my vertices, which are 3, 2, and -1, 2. Or I could have taken my center and added and subtracted the A from the X coordinate because the vertices are on the horizontal. The co-vertices I can also get from my graph by going up and down. So this is 1, 5, 1, -1. Or I could have taken my center and added and subtracted the B from the Y coordinate because the co-vertices are vertical. And then the last one is the foci, and for those lie inside my parabolas, so those are inside my branches, so those are going to be right and left again. Because C is like root 13, I'm going to approximate that to be, I don't know, like a little bit bigger, in between 3 and 5, 3 and 4, let's say. So 1, 2, 3, it would be like here, and 1, 2, 3 here. So if it asked you to graph it, you would do that. But to actually identify the point, you're going to keep it as root 13. So that's on the X. I'm going to take my X coordinate of my center, which is 1. I'm going to add and subtract the square root 13. And my Y doesn't change. And then there's my asymptotes. So it said center, vertices, foci, asymptote. Questions? You're going to get given all different kinds of information, so you got to know this stuff so well that you would know it based on the information that they give you, how to figure it out. You could get the foci. I mean, you could obviously get the equation like this one, or with the last one, you can get the foci and the vertices. You can get the co-vertices and the vertices. You can get the co-vertices and the foci. You can get the asymptotes. You can get the transverse axis or the conjugate. Remember, transverse is like your major, which in this case would be horizontal. And your conjugate is your minor, which in this case would be the vertical. Those are 2A and 2B, just like your major and your minor. Questions up to this point, because again, we're going to build on it. All right, so we're going to start super easy, and then we're going to get super fun, and by super fun, I mean you're going to hate every second of it by rotating the conics. All right, so the first part is finding the type of conic based on its general equation. So this is not in standard form. If it's in standard form, hopefully it's easy to identify what it is. But let's say it's not. Like, let's say I give you the one that I just gave you before you complete the square. Then you can identify the type of conic by the relationship between the A and the C. The A is what's in front of the X squared. The C is what's in front of the Y squared. If they are equal, then this conic is a circle. If their product is 0, which means one of them is missing, because then it would be 0, then it's a parabola, which should make sense because there's only one squared in a parabola. If their product is not 0 but is positive, then it's an ellipse. And if their product is negative, but they're not the same, then it's a hyperbola. So these are super easy. You're going to get given an equation. You're going to identify your A, your C, figure out the relationship between there, and then classify the conic. All right, so example 5 says classify the graphs of each equation. So if I look at example A, what is A on this equation? 4. What is C? There's no C, which means 0. What is this type of conic? A parabola, right? That product would be 0, which makes it a parabola. Looking at B, what is A? 4. What is C? -1. So their product would be a -4, right? Which makes this hyperbola. Go to C. A would be what? 2. C is 4. That's a +8, which makes this an ellipse. Good. And then the last one, A is 2, C is 2, which makes this what? A circle. So be careful because it's positive. People will write positive and put ellipse. But if they're the same, it's a circle. Easy stuff, right? Questions? Okay. So now we're going to learn what happens when we rotate these conics. So what happens when our axes are not vertical and horizontal? So we start by just learning what a rotated axis is. To eliminate an xy term, which is what's going to happen to make them rotated, is you'll actually have an xy term. So up until this point, if you look at every single question you've done in class or for homework or for warm-up, not a single one of them had an xy term. An xy term means that conic is not vertical or horizontal, it's rotated. So to eliminate it, we're going to use a procedure called rotation of the axes. The objective is to rotate the x and y axes until they are parallel to the axis of the conic. The rotated axes are denoted as the x, and that little mark is read as prime. So that is the x prime axis and the y prime axis shown. So this is read as prime. So if you look at this graph that's here, here's your normal x and y axis. This is what we're used to. So what happens if it rotates is that you will take the x-axis and actually shift it up whatever theta is. So this one looks like it's a little bit less than half. Maybe say this is like 40 degrees. This is an axis that's been rotated 40 degrees. So you're going to rotate it counterclockwise in the direction of your unit circle. Okay, so think about the top would be 90 degrees, the left would be 180, the bottom would be 270, and all the way around. Okay. So example 6 says the x prime y prime coordinate system has been rotated theta degrees from the x y coordinate system. The coordinates of the point are given. Find the coordinates of the point in the rotated coordinate system. So the first thing I'm going to do is pull in a graph so that you can see what this would look like. And what it's telling me is that theta has been rotated 90 degrees, but my initial point is at 4, 0. So if I plot my initial point at 4, 0, which is there, now I need to figure out how it's been rotated, rotate it, and then determine the coordinate points once it's rotated. So if this is where x normally is and this is where y normally is, and I tell you that x is being rotated 90 degrees, where is 90 degrees? At the top, right? So I'm actually taking this and I'm rotating it 90 degrees, which means this is now the x prime axis. Here's the challenge. I need to rotate this back the other way so that x prime is where x is supposed to be. So I'm actually going to physically take that graph and I'm going to rotate it back to the right so that x prime is where x is supposed to be. You won't be able to do that with a piece of paper, right? You can't take just a part of the graph and rotate it. You can't do that in Notability, which means you're going to physically take your iPad or physically take your piece of paper, mark where x prime is, and then rotate it around so that x prime is where x is supposed to be. So the initial marking came from rotating it that many degrees counterclockwise in the direction of your unit circle, and then rotating it back clockwise so that the x prime is where my x is supposed to be. Does that make sense?
Why wouldn't it go like that?
Because you need x prime to be your new 0. So you're marking it wherever it is. Let's say that I said theta was 120 degrees, right? So 120 degrees is here. That's my x prime. I need x prime to go back to 0. So I would rotate it all the way back around till it goes like that.
So it's the opposite?
Yep. So you're marking it counterclockwise like we do with our unit circle. But then when you rotate it, you're rotating it back to where that would be 0 again. Miguel.
How do you mark it, like if you were going to do it on paper?
So I would physically, so like if this was paper, I would have done that exactly the same, the way that it is. And then I would take my paper and rotate it.
Is that like for us to graph it and then we move it back? Or is it staying like that?
Once you rotate it, it's staying like that. I mean, you'll turn into, your test to me will be rotated, but yeah. Like take your iPad. That's what it looks like right now, yeah? But x prime's at the top. I need x prime to be at the right. So take your physical iPad, rotate it. Now it should be in, but don't let it shift. Does that make sense? Like don't let it change from portrait to landscape. Keep it flat. Yep.
Like when you flip this, would you mark 4, 0?
So this is where it is now, right? If you actually rotated this is what it looks like now. This is my x prime, which means this is my y prime. I'm not moving the point, I'm giving it its new name. So on that rotated axis, what's the coordinate point of that point? 0, -4, right? It's down.
Oh, so we do the point first and then we...
Correct.
Oh, okay. So the point that like you're looking for is the one you started?
Correct.
Okay, so when you move the graph, so you
Yep.
graph the original point, and then you flip it so then the arrow is where it's supposed to be,
Mm-hmm.
but just like reversed.
Mm-hmm. So that's, yeah, 0, -4 would be the answer to this one. So let's say theta was 180, still coordinate point at 0, 4. So coordinate point still starts same, 4, 0. Where is 180? On the left. This is now x prime. Yes, x prime. So I'm going this way to mark it, but then I rotate it back the other way. Now what's the coordinate point there?
Is the answer always just going to be opposite?
No, because it depends on what the angle is. Yep.
I was going to say, couldn't we just like write the opposite of it?
So what's important, like this little component is so small in comparison with what we're about to do. The important part is, do you know how to rotate it? And if you could rotate it, then can you graph on it? So this is not even the big part, but you have to understand this is the hard part to grasp. Once you understand this, then we go through the long, tedious process. Okay? So what's important is learning the rotation of it. Okay? Questions? That was my easy part. Okay, so now we're going to learn what we're going to do with, we're going to take our conics and rotate them, okay? So the difference, I said it already, but the difference between what we had done up to this point and what we're going to do moving forward is that you never had an x, y term before. If you look at all the examples we've had, even if you had to complete the square, there was never an x, y term because we couldn't have completed the square on those. So now a rotated one's going to have an x, y term. And you actually have to work to eliminate the xy term so that you can graph it, okay? So the first thing you're going to do is you're going to identify A, B, and C. A, B, and C. A comes from the x squared term. B comes from the xy term. C comes from the y squared. So A is x squared, B is xy, C is y squared. Those are going to be constants. That's step 1. Then you're going to find what theta is by using that little formula that's there. The cotangent of 2 theta equals A minus C over B.
Is that like in stone? Or is that
Yep, nope, in stone. From there, you'll get a theta, and that theta is the rotated angle. So if that theta is pi over 2, we will rotate it up to pi over 2 and turn it back to graph it. If that theta is pi over 4, we'll rotate it up to pi over 4 and rotate it back to graph it. Whatever you get from that is going to be theta, right? So let's say the answer to that is pi over 3. Then when I look at my graph, I would find pi over 3, which is up here, make that my x prime, and then rotate it around and graph it on that new axis. So your conic will be graphed on the new axis. So much fun. You have no idea. Why? Because it's one of the skills you need to know, especially for your test on Thursday. Okay, then step 3 is finding the x and the y. So the x equation is x prime times the cosine of theta minus y prime times the sine of theta. And the y is x prime times the sine of theta plus y prime times the cosine of theta. The good news is those are going to get given to you. This you've got to memorize. Well, not that. This. Then after that, you're going to plug x and y back in. And get the remaining equation into standard form.
when you plug it into this computation?
Whatever is going to get given to you. And once you simplify it, you will see you're either going to get an ellipse, a hyperbola, a circle, or a parabola. And you will graph that conic on the rotated axis. This is a tedious process, okay? It is the same steps over and over again, however. So this is one of those types that the more you practice it, the faster and more careful you're going to be because you'll be so familiar with it that it becomes second nature. If you try to do this once in the next 2 days and then try to do it again on the test, good luck to you, my friends, okay? This is one of those things that takes a long time, but the steps are repeated. And there's a fixed number of angles I can give you because they all are unit circle based. So if you have practiced this over and over again, then you should be good to go. All right. We're going to start easy. Example 6 says rotate the axis to eliminate the xy term in the equation xy minus 1 equals 0. Then write the equation in standard form and sketch its graph. So that is a conic disguised. Okay, it's one of the conics we know, but right now it doesn't look like it. It's disguised in a different way. We have to eliminate the xy term, and in doing so, we'll put something into standard form that has to be graphed on a rotated axis. So the first step is find A, which is in front of the x squared. What's that? 0. B, which is in front of the xy. 1. C, which is in front of the y squared. 0. And then cotangent of 2 theta is A minus C over B. So this is 0 minus 0 over 1, which is what? 0. So cotangent of 2 theta equals 0. Now comes the unit circle. The good news is you only need to know the first quadrant. And I've forced you to learn this so many times that this is second nature to you now, right? This is 0. This is pi over 6. This is pi over 4. Pi over 3. And pi over 2. Coordinate points are 1, 0. Root 3 over 2 and 1/2. Root 2 over 2 and root 2 over 2. 1/2 and root 3 over 2. 0, 1. And I'm even going to go the next step and add on the tangents. This is 0. This is root 3 over 3 because it takes 2 3s to make the 6. This is 1. This is root 3 because you only need 1 3 to make the pi over 3. And this is undefined. Questions? So if that's like shady for you, if that's a little bit rough, make sure you review it because you're going to need to know it. So if all that's true, and I go back to my equation, which says the cotangent of 2 theta is 0, cotangent's not on my circle, right? I didn't write those on there. But if cotangent is 0, then what does that mean tangent is? What's the reciprocal of 0? Undefined, right? That would have been 0 over 1. If I flip it, it's 1 over 0. That's undefined. Does that make sense? So really, I'm saying that the tangent of 2 theta is undefined. And so the angle there is what? Where is tangent undefined? 90 or pi over 2. Normally, if that 2 is not there, if this isn't here, then we would just say theta is pi over 2. But that 2 is there. This is one of your multiple angle equations. So this is really saying 2 theta equals pi over 2, which means to get to theta, I have to do what? Divide by 2 or multiply by 1/2. And theta is pi over 4. That's step 1. You do this 4 times in the next 3 days, and you will do that in about 30 seconds, okay? You do that once in the next 4 days, and you're going to stare at this test for a long time. The good news is that that's a checkpoint. So if you can get to there, I'll give you some points, okay? Obviously, that's a small part of the big thing. But at least you get there. Like, if you leave this question blank, I should be able to beat you over your head with your own test, okay? You get to there, at least you get some points. Then step 2 is find the x's and the y's. So 2 says x equals x prime cosine theta minus y prime sine theta. Y equals y prime cosine theta plus x prime sine theta. Let me be consistent. So this should be just reversed order. It doesn't really matter because they're both addition, but I'll follow what it said. All right, so now I know theta. That's what I'm going to plug in. So I'm going to say that x equals x prime times the cosine of pi over 4 minus y prime times the sine of pi over 4. And then y equals y prime times the cosine of pi over 4. Oops, no, let me do it though. X prime times the sine of pi over 4 plus y prime times the cosine of pi over 4. Do you know the sine and cosine of pi over 4? Yes, it is what? Unit circle. Pi over 4 is here. What's true about the x and the y? They're the same, but remember the x is the cosine, the y is the sine, because obviously they're not always the same. So this is now x prime times root 2 over 2 minus y prime times root 2 over 2. Or root 2 times x prime minus root 2 times y prime all over 2. So get it as simple as you can. God bless you. They will always have the same denominator because whether it's root 3 over 2 and 1/2 or root 2 over 2 and 2, Those will always have the same denominator, and then obviously the other ones have whole numbers, zeros and ones. And then y, I'm going to do the same thing, thank you. Y equals x prime times root 2 over 2 plus y prime times root 2 over 2, or root 2 x prime plus root 2 y prime all over 2. That's second checkpoint. So first is theta, second is x and y. With me so far? Now I take those and I plug them back into the original equation. So x minus y, or sorry, x times y minus 1 equals 0 is my original equation. My x, Yep, so this is kind of like step 3. And there's a lot of steps in between, but yeah. The x is root 2 times x prime minus root 2 times y prime over 2. The y is root 2 times x prime plus root 2 times y prime over 2. Minus 1 equals 0. Now I got to multiply that out. So the good news is there's 2 skills that you learned in Algebra 1 and Algebra 2, and again, we've talked about it this year, that help you with the speed of this, okay? One is what happens when the 2 terms I'm multiplying by are the same, but the sign in between is the opposite, meaning what happens when I get x plus y times x minus y? I get x squared minus y squared. That xy in the middle would cancel out, yes? So that's a difference of 2 squares, right? So if you look at your equations that are there, the part that we just wrote out, looking at the numerators, they are exactly the same, but one's a plus and one's a minus. Does everybody see that? Which means I can take the first term, which is root 2x prime, and I can square it. And I can minus or subtract the second term squared, root 2y prime squared. And then 2 times 2 is 4, minus 1 equals 0. So there are going to be shortcuts that help you out, and they come from your Algebra 1 skills. The other one is like a square of a trinomial, which we'll talk about in a second. So what's root 2 squared? 2, and that's x prime squared. Minus 2 again, y prime squared, over 4 minus 1 equals 0. Now I got to get this into standard form. So I'm going to split it up. 2x prime squared over 4 minus 2y prime squared over 4. I'm going to bump that one to the other side. And then I'm going to reduce. So x prime squared over 2 minus y prime squared over 2 equals 1. And there's my standard form. That's your third checkpoint. What kind of conic is this? You sound so sure. The only one has a minus between it, right? Yeah. This is a what? Hyperbola. What's the center of my hyperbola? Is this vertical or horizontal? A squared is 2, making a root 2. And b squared is also 2, making b root 2. Can that happen? Have we had a hyperbola with a little square in the middle? Yeah, right? It's fine. Everybody with me so far? Because now I got to graph it. No, because this is, you're going out those directions, right?
Oh, wait, okay.
Because it's not technically, that's a negative between them, which would make it different. Okay, so now we pull in a graph. And the first thing I have to do is rotate my axis. What did we say theta was? pi over 4, which is right in the middle at 45 degrees. So now I'm going to take that, I'm going to rotate it so that it is on the side where my x should be. I'm going to draw, that's my x prime, this is my y prime. And then I'm going to plot all the information I just found out about my hyperbola. My center is at 0, 0 on the rotated axis because it's x prime. I'm going to the right a, which is root 2. Let's say that is approximately 1.2. I'm not even going to get that exact because it doesn't really matter as long as I'm just past 1. So I'm going to add my own tick marks because they don't exist. I'm going to go just past 1 to the right. That's my vertex. To the left, that's my vertex. Up, that's my co-vertex. Down, that's my co-vertex. I'm going to draw my little box. I'm going to do my asymptotes. And we said this is horizontal, so on my vertex, I'm going to draw my branches. So when you turn your paper into me, it's going to look like this, right? Because that's how your paper, you can't adjust just part of your paper. But when you get your test, that's what you're going to want to do. You're going to take your equation. Once you get theta, you're going to want to rotate your total paper so that the x prime is on the right-hand side. Graph your parabola, your ellipse, or your hyperbola, whatever the shape is, along your new axis. Yep.
How much is this question worth?
I don't know yet. I'm working on point value, but it'll be a lot. Yeah. All right, same set of directions. Oh, this shouldn't be here. This is a new equation. So rotate the axis to eliminate the x and y term in the equation. Then write the equation in standard form and sketch its graph. So the very first step is identify A, B, and C. What's A? 13. What's B? 6 root 3. What's C? 7. So cotangent 2 theta equals A minus C over B. 13 minus 7 over 6 root 3, which is 6 over 6 root 3, or 1 over root 3. Now before you go rationalizing that, remember we flip it to get to tangent. So this is really saying the tangent of 2 theta is the reciprocal of that, which is root 3. Everybody with me so far? So that's the first part. Then I want to go back to my unit circle. I would look at which one has a tangent of root 3, which is pi over 3. And I would say 2 theta equals pi over 3. Divide both sides by 2, which is the most common mistake people forget to do. And I get theta is pi over 6. That's the second checkpoint that's going to earn you some points. Everybody with me so far? Then it's just plugging in. So I'm going to give you x equals x prime cosine theta minus y prime sine theta, and you'll take that and plug it in. So x equals x prime cosine pi over 6 minus y prime sine pi over 6. And you're going to remember that pi over 6's point is root 3 over 2 and 1/2, which makes cosine root 3 over 2 and sine 1/2. And then we're going to put them all on 1. So this would be x equals root 3 x prime minus y prime all over 2. That's the x. And I'm going to repeat that process for y. So y equals x prime sine theta plus y prime cosine theta. Y equals x prime sine of pi over 6 which is 1/2, plus y prime cosine pi over 6, which is root 3 over 2. And I get y equals 1 times x prime, or x prime, plus root 3 y prime all over 2. Still with me? Questions to that point? All right, so now this comes up to that point. Honestly, it's kind of the same level of difficulty as the last question, but this is where it ups it, right? Because now I got to plug them back in up here. So I'm going to get 13x, which is root 3, and I'm actually going to leave off the primes for the purpose of working this out, but at the end, I'm going to make sure I put them back in. Plus 6 root 3x times y plus 7 times y squared minus 16 equals 0. Questions so far? Okay, so the second algebraic skill that you learn that's going to help you here is squaring a binomial. So when you square it, meaning they're the same, and you'd be foiling that out, okay, the shortcut is take the first term and square it, take the last term and square it, and then double the product of the two terms. So you can use that everywhere there's a squared. Square the first, square the last, and then double the product of the two terms, and that's going to be your middle term. If you get lost on that, then expand and FOIL it. All right, so we're going to go first term. So I get 13 on the front, and I'm going to square this. So the square of root 3x is 3x squared. I'm going to square the negative y. That makes that positive y squared. And then I'm going to double the product. So this is negative 2 root 3xy. And then 2 squared is 4. Then I go to the next one, plus 6 root 3. This time, it's not squared. And they're not the same terms with a plus and a minus, which means I actually have to FOIL these out. So first is root 3x squared. Outer, root 3 times root 3 is 3xy. Inner, minus xy. Last, negative root 3y squared. And all of that goes over 4. And then this becomes 2xy, a positive 2xy. Questions on that one? Okay, then comes plus 7 times, this time this is squared. So I can use the shortcut, first squared, last squared, double the product. And then 2 squared is 4. Minus 16 equals 0. Question so far? All right, what do we notice about all the denominators on these fractions? They're all 4. So something that you could do to help yourself out along the way is eliminate those 4. So if I were to multiply everything here by 4, this is going to cancel, this is going to cancel, this is going to cancel. This becomes 64, and this would be still 0. So that step leaves me 13, 3x squared minus 2 root 3xy plus y squared plus 6 root 3x squared plus 2xy minus root 3y squared plus 7x squared plus 2 root 3xy plus 3y squared. And I'm going to bump the 64 to the other side because I'm going to have to eventually do it anyways. So that equals a positive 64. Then you have to distribute in on all your terms. So 13 times 3 is 39x squared minus 26 root 3xy plus 13y squared. Go to the next one. Plus 6 root 3 times root 3 is 6 times 3 or 18x squared plus 12 root 3xy minus 6 root 3 times root 3, which is minus 18y squared. Go to the next one. Positive 7x squared plus 14 root 3xy plus 21y squared equals 64. Now I'm going to find my like terms. Before I even do that though, while doing that, I pick out the x, y terms first because the whole goal here is to eliminate the x, y. So if you have done that wrong, this is where you catch it because these should cancel out. So I have a negative 26 root 3 plus 12, that's negative 14 root 3. Plus 14 root 3, and those cancel out. So if you've done it correctly, that will happen every time. The goal is to eliminate the xy. Then I'm going to add all my x squared terms. So I've got 39 plus 18, 57x squared, and then 57 plus 7, which is 64x squared. Then do my y squared, 13 minus 18, that's negative 5, plus 21, that's positive 16y squared, equals 64. So all that work gets you back into your pretty standard form. Divide everything by 64. Make sure you put your primes back in. So x prime squared over 1 plus y prime squared over 4 equals 1. What kind of conic is this? It's a plus, but they're different, right? Which means an ellipse. Center is 0, 0. A is 1. No, A is 4. Sorry, it's the bigger one. A squared is 4, so A is 2. And B is 1. So I take my axis, I rotate it, what theta is, and theta was pi over 6. I'm going to rotate that around so that it's easier to graph. This is my x prime, this is my y prime, 0, 0. This is A. The 4 is under the y, so this is vertical, which means I go up 2, oops, sorry, up 2, down 2, right 1, left 1, connect my ellipse. So in the end, my answer would look back like that. So be really, really careful. Your homework has 3 questions. Obviously, these take a long time. And if you show me no work, you will get no credit. There will be no mercy on somebody that just picks a multiple choice component. You have to show the work on these and then choose your graph based on your work because your test is not multiple choice. So be really, really careful.